In the next series of videos, we are going to cover section 10.5, Euler and Hamiltonian graphs. So by the end of this section, you should be able to determine whether a graph has an Euler circuit or an Euler path, and you should be able to determine whether a graph has a Hamilton circuit or a Hamilton path. You will also be able to construct one if it exists, or be able to explain why none do exist. You will also be able to use algorithm 1 for constructing Euler circuits to construct Euler circuits. Given our experience in both constructing algorithms and using algorithms to solve problems at this stage of the course, we're not going to cover this algorithm within the videos, particularly because the notes that accompany this algorithm are pretty straightforward and completely laid out for you, so you should be able to simply read them and be able to understand and apply this algorithm yourselves. However, if you do have any problems and have any questions, post them to the forum or ask them in class, and I would be happy to answer them for you. Okay, so let's begin with Euler paths and circuits. So these were defined by the famous mathematician Leonhard Euler in the 18th century, and he defined them when trying to solve a real-world concrete problem. So let's talk about that problem. So in the town of Königsberg, Prussia, which is now Kaliningrad, Russia, it was divided into 4 sections by branches of the Prigel River. So here are these 4 sections, and the river is separating each of these sections. And in the 18th century, 7 bridges connected these regions. And so people of Königsberg wondered whether they could leave their home, cross every bridge exactly once, and return back home. And so the Swiss mathematician Leonhard Euler was able to construct a graph model depicted here of this particular situation and defined Euler paths, and most specifically Euler circuits, in order to be able to solve this problem. So let's look at this graph. So this is a model of this particular situation where each of the vertices is a section of the city, and each of the edges are the bridges that join those sections over the river. And Leonhard Euler defined an Euler circuit to be one which satisfied this problem. So it's a circuit in which you traverse each of the bridges exactly once and return back to that same point. The solution to this problem is actually considered to be the first ever theorem proved using graph theory. So this is considered to be the first ever graph model of a particular situation, and the Euler circuit was defined to be able to solve this problem. Now, unfortunately, it turns out that this graph does not have an Euler circuit, and so the answer to this problem is in fact no. And we'll be able to determine that once we formally define what an Euler path and an Euler circuit is, and then later develop criteria or characteristics so that we're able to determine almost instantly whether a graph has an Euler circuit or an Euler path or not.